Bella, I am going to go through these. This is just a questions I took from past papers relating to exponents. We need to simplify here. And for you to simplify, you need to simplify to the simplest exponential form. Let's start with the first one. How do we simplify the first one? Um, Basically, this is what you have here. I'm just going to highlight the bases that I need to prime factorize. And these are the bases that I need to prime factorize. I will start with 81. So with 81, you just press 81 into your calculator, you press the equal sign, then you go to shift and it'll be 3 to the exponent of 4. So instead of writing 1 there, I'll write that 3 to the exponent of 4. And when it comes to 27, you'll say 27 equal sign. Then you press shift, factorize, it'll give you 3 cubed. For 9, you know that will be 3 squared. Okay. What I'm going to do when I prime factorize, I'm going to put them in brackets and note that this exponent of 27 is still x plus 2. It's just that I'm changing 27 itself. So when I change 27, it will be 3 cubed. And when I change 9, it will be 3 squared. Okay. So all I did here was just to prime factorize those. Basically, all I did was just to change the bases and prime factorize them. The exponents are still the same. I still have 27 to the exponent of x plus 2. I still have 9 to the exponent of x minus 1. I still have 81 to the exponent of x plus 4. This is 81. This is 9. This is 27. Now, when it's like this, all you have to do, guys, is to distribute the exponent. Now, through all grades, even grade 12, they don't do this. They struggle with this. When you distribute the exponent, I'll start with the first factor. I'll just start with this here. So with the exponents, know that brackets mean you need to multiply, but here we're not multiplying the bases. Instead, we are multiplying the exponents. So you will multiply whatever is inside the bracket with what is outside the bracket. Inside the brackets, we have an exponent of 3. So this exponent of 3 must be multiplied with the whole exponent of x plus 2. We need to multiply it with the whole exponent of x plus 2. And to multiply it with, it's a monomial multiplied by a binomial, which will give you a binomial. So 3 times x will give you 3x. 3 times 2 will give you 6. So this will give us 3x plus 6. The next one, we are multiplying 2 with x minus 1. And how much will this give us? It'll give us 3x, 2x it'll give us 2x minus 2. Okay, obviously that one relates to this one here. And the one in the denominator, I'm taking 4, I'm multiplying it with x plus 4. And we do the same thing. 4 times x will give us 4x. And 4 times 4 will give us 16. And that's how we got to this here. Now, once you have simplified it this way, where you have multiplied the exponents, there's nothing else you can do. In the numerator, you will notice that you're simply multiplying a base of 3 with a base of 3. So when you multiply, the bases are the same, you just add the exponents. So I'm going to add 3x plus 6 with 2x minus 2. And in the denominator, I also have a base of 3 and a base of 3. When I multiply same bases, I will add the exponents. So I'll have x minus 1 plus 4x plus 16, which will give me this. You know like terms by now. So you will simply take 3x, add it with 2x, that will give you 5, and 6 minus 2 will give you 4. That is for the numerator. In the denominator, we have x plus 4, it'll give us 5x, and negative 1 plus 16 will give us plus 15, and this is what we've got. Now you can simply say the bases are the same. We are dividing, you just subtract the small exponent from the big exponent. Okay, that's how you can look at it. All I did here was simply to subtract the denominator exponent from the numerator exponent. So I took the whole of the denominator exponent and I subtracted it from the numerator exponent. So it's 5x minus 4 minus 5x minus 15. Okay, and this is what I've got. 5x and 5x then will give us 0, and 4 minus 15 will give us 3 to the exponent of negative 11. Because the exponent is negative, that negative we can write it as 1, and the base and its exponent will go to the denominator. So we'll have 1 divided by 3 to the exponent of 11, and 1 divided by 3 to the exponent of 11. 3 to the exponent of 11 will give you 177,147. And that's it. Simplify. Easy, right? Try this one out. What are we going to start with? Prime factorize 36. So 36 equals sign, then you press shift and back, it'll give you 2 squared times 3 squared. Okay. And the next one will be 12. So I'll have 12 shift, and that will give us 2 squared times 3. And obviously 8 will be 2 cubed. So all I need to prime factorize here is that 36, 12, as well as 8. And this is what I get when I prime factorize them. Now, all I have to do, guys, is to take this 2, times it by the outside exponent. So I'm going to times it by x, and then times it by negative 2. And that will be the exponent of the base 2. Okay, so the exponent of the base 2 will be 2 times x minus 2. And I'm allowed to distribute when there is a multiplication. So I'll still multiply the exponents here. But when I multiply the exponents, I will now multiply the exponent of 3 with the outside exponent. So it'll be 2 times x, and the 2, you times it by negative 2 again. So that will be the exponent of 3. In the denominator, you're going to do the same thing. This 3 here has an exponent of 1. So you will multiply it by this 2x, 1 times 2x, and 1 times negative 3. And do the same thing with the exponent of base 2. So with the exponent of base 2, you will take this 2, times it by 2x. So it's this 2, times it by 2x. And the same 2, you will times it by negative 3. Okay, this one is quite easy because you will just take 3 times x and then 3 times 1. All right, so basically this is what I have when I simplify them. Now, I have already explained. So the exponent of the first base, which is 2, the exponent of this 2 here will be 2x minus 4. The exponent of this 3 here will be 2x minus 4. The exponent of this 2 here will be 4x minus 6. The exponent of this 2 over here will be 3x plus 3, which is this one over here. Now note that I have a base of 2 in the numerator. With a base of 2, I will add the exponents when I multiply them. Similarly, in the numerator, I have a base of 3 as well as the base of 3 that multiplied. Therefore, I will represent them as a single base and just add the exponent. This 3 has an exponent of 1. So when I add the exponents of 3, I'll have 2x minus 4 plus 1. In the denominator, I have a base of 2 multiplied by the same base of 2. So here I have 2 multiplied by base of 2. So I will just add the exponents, which will be 4x minus 6 plus 3x plus 3. And that's what I will have. I can't multiply now, I just have to divide. Okay, when I divide, all I'm going to do with respect to the 2's, I will simply take this one here and subtract that one over there. It'll basically be 7x minus 4 minus 3x plus 3. When it comes to the 3's, because it's the same base with the same exponents, those ones I can just cross them out. As you can see here, all I did was just I took 7x minus 4. This 7 here, because it was positive, when I moved it to the numerator, it became negative. And this 3 here, because it was negative, when I moved it to the numerator, it became positive, okay? That's why we've got 7x minus 4 minus 7x plus 3. Now, 7x and 7x, ziyaqedana. In essence, they will give us 0, right? And minus 4 plus 3 will give us minus 1. So we'll end up having 2 to the exponent of negative 1. Now, because the exponent is negative, I'm going to take the numerator of 1 and divide it by the same base with its exponents. I'm going to divide it by 2 with its exponents. So 1 divided by 2 and its exponent, which will be 1 over 2. So note that its exponent is still 1. It's just that when the exponent is 1, we do not write it. Okay, so it's 1 divided by 2 to the exponent of 1, but that exponent of 2, because it's 1, we do not write it. We still good. All right, I did the first one and the second one. Please finish off the rest. Just do 3 up to 6. All right. Be on the lookout for the next video as we go through those as well. Hold on.